Patrick Gundlach will talk about boxes and glue.
So thank you very much. This is a follow-up from my last year's presentation on boxes and glue. And when I submitted the paper, I thought about talking on news on boxes and glue, but that would have been a very short presentation. So how does it work? This. Okay, I changed the title internally to Lessons Learned. And maybe it's a mixture of both. So before I go into the details, I would like to have a short recap on what is boxes and glue. So boxes and glue is a collection of software libraries. It's not a ready-to-run piece of software, so it's not an application. It's written in Go. It's the attempt to bring text-superb output quality to a modern environment, and it's, of course, open source. So why do I create, or why have I created boxes and glue? My day-to-day work is to create product catalogs and other similar documents. I use software built on top of LuaTeX, and it works really well. And LuaTeX is a totally awesome piece of software, and it's very good. But LuaTeX has limitations. For example, some trivial limitations, like it cannot do any HTTPS requests. I don't know if it's still true, but at the time I looked at it, and I need this every day. So I had to write a wrapper around it, and there are also other limitations which made me to think about writing a replacement for LuaTeX. So since I've used LuaTeX a lot, the implementation of boxes and glue uses the same data structures and the API of LuaTeX, especially the nodes, like the small pieces you have on the paper, on the page, the glyphs, rules, and so on. The node packing algorithms like hbox2, whatever size, and bbox2. Everything is a rectangular item, maybe stacked together. The line breaking algorithm and the hyphenation algorithm and a few other things. So these are very similar in LuaTeX and boxes and glue. Hello? Okay. Last year I've also presented the architecture of boxes and glue. So it is split into two parts, a backend with all the necessary parts to create PDFs. For example, the nodes are in here, and the line breaking algorithm, and some other necessary stuff. And there's a nice to have front end, which is not strictly necessary. You can have like CSS, HTML typesetting in there, and collection of font families and so on. So it's built on top of the back end. And of course, you need some kind of application that uses these libraries. And last year, I've also presented some kind of progress bar, how far I got with the implementation. And it was like this. And now comes the news from boxes and glue. You have to watch carefully. This year, it's it's a bit more. So I think the backend is more or less complete. So you can write PDFs, and there's pretty good support for it. And this last year, most of the work has been done in the CSS, HTML backend. And there's also some progress in the applications. Currently, I'm working on two. The main application I use is the catalog software, which is a direct replacement of my software I use currently. And some HTML, CSS typesetting. We just put in some web page with CSS, and you get a nicely printed PDF document. So talking about history, some time ago I ported the hyphenation algorithm to LuaTeX, and somebody commented, "Are you going to port LuaTeX to Go?" I said, "Oh, it's a long-term project," and so on. That was 7 years ago. So I think that was pretty much the start of boxes and glue. Maybe I'll give a short timeline. I experimented in the beginning with taking the web source code from Knuth. I started with DVI type, which is a very small program, and I tried to rewrite this in Go one by one, like taking exactly the same data structures and code and so on, just change the syntax so it compiles with Go. And after finishing that, it works, but I said, no, I'm not going to do this because it's not extensible. It's still the same code, but it's hard to extend. So I thought a long time about how to do this, and then I started rewriting the algorithms from TUG into Go. There I started with the hyphenation algorithm, did some other things. Then I did some typesetting experiments. And 2 years ago, I started the first commit, or the first code on boxes and glue. I tried a Lua front end, but I threw it away because it was too early at that time to have an API. Since I use XML a lot, I also had to write an XPath library and some XML stuff. And the XTS stands for Experimental Typesetting System, or XML Typesetting System. Is the one I use currently as a test bed to continue the development. So currently I work on CSS, HTML typesetting, and hopefully next year I will have the first productive use. So there's, I can see the end of the first version, or the beginning of the first version. So my next steps or wishes are right to left and left to right typesetting like Arabic. And I also need some kind of graphics library. Metapose is very nice, but it doesn't exist in pure Go, so I need to find some replacement for that. Also, I would like to have a paragraph shape to have text wrapped around images, for example. So this is also from last year, my design goals of boxes and glue. So I would like to have TUG output quality, performance. I would like to see the TUG data structures, and left to right or right to left, or mixed bidirectional typesetting, and to support PDF standards, a variety of PDF standards. And I also have a progress bar here. So there are some parts better than the others. And the second item, the performance, is quite important for me. LuaTeX is very fast, contrary to what people say. With plain TUG macros, I get 500 pages per second with LuaTeX. And I did some benchmarks yesterday with my catalog software, which has some kind of macros or stuff, layers on top of LuaTeX. I get about almost 50 pages per second, which is also quite fast. With boxes and glue, I'm currently at 300 pages per second with the same document. So I think this is quite okay. So lessons learned so far. It works, yes. It's not a really lesson. Writing PDF can be difficult. And again. So it works. The middle one is some CSS, HTML typesetting. And the right one was an example from my old catalog software, which I have now ported to the boxes and glue. So there is output possible, and I'm really happy with it. Next lesson learned is like PDF can be difficult, writing PDF can be difficult. PDF looks like an innocent file format. It's just plain text and a bit of binary data, so it's actually not that hard to write. But the spec has around 1,000 pages, and there's not only one spec, but you have to read different kinds of specs. So you can see from that number that it's not that trivial. But it is innocent or easy at the beginning. For example, to include a PNG or bitmap image, you can just write an object, which is a dictionary, type X object, subtype image, and then some parameters, and then the compressed data. You put this in the PDF file, and you actually get an output. And I say, ooh, that's easy. Then I came up with the next image. I tried to include this. It came out like that. You see the strange four corners? I said, okay, no, what happened here? And I finally found out that these four corners are transparency. So I had to look up the spec again, find out how transparency is implemented with bitmap images. I implemented this and I said, great, finally got it. So I tried to include this image. This is a gradient also with transparency. It came out like this. Ah, no, bummer. So I had to reread the spec, debugged a lot, and finally found out, okay, if this is some kind of soft mask, we have to write a different kind of object and include this as a transparency object. I finally got it, and it came out like this. And I said, no, okay, I read this back. Got it, finally. So then I prepared a presentation for TUG. I tried to include this image, and it came out like this. You see the small white line. I said, okay, maybe that's a display error in my PDF, or the display is broken, but no, it didn't go away. So I had to reread this back and fix some errors. So it's trivial to start, but the devil is really in the details, and it's also with fonts and other things. So it's easy to write, but you have to consider a lot of things. So writing PDF is hard, I think. And again, but not less and less and less. So I'm still as clever as before. So I always encounter errors. So there are different kinds of errors I encounter. For example, I put this table and one cell just was shifted a bit too high. Or this funny T, I call this, I don't know, somehow the T just appears incorrectly. I fixed that bug finally, but I was not happy with it at the beginning. But most of the time, when I create an error, it looks like this. I get an empty PDF, and I said, okay, thank you. And then I open the PDF in Acrobat, and Acrobat tells me, an error has occurred, or please contact the person who has created the PDF. Glad I have his phone number. So, actually, gladly there's, in Acrobat there's a way to check for errors. Okay, there's a pre-flight menu in Adobe Acrobat. We can select the item, check for errors. And then it will analyze the PDF, and you might get an output like this. It might be hard to read, but it says, okay, on page 2, you have an error on this object, and this key is missing. So you really get to understand, okay, this is what I've done wrong. Then you can fix it. And when you're lucky, you get like this. Or if you're totally unlucky, you also get this. Because sometimes I open the PDF, it says, no, it's totally broken. Call the author, the creator of the document, and then I do the error checking, and it says, okay, no errors found. So it's hard to debug errors in the PDF. Tools for PDF debugging. As I said before, I use mostly Adobe Acrobat to check for errors. But sometimes I open the PDF in the text editor or read it with less, because it's a plain text file. And you can just ignore the binary data. You might have to decompress it first if you're looking for foreign PDFs which are compressed. But you can do this with QPDF. And opening it in text editor is very good to read. There's also Vera PDF. It's an open source checker. And for accessibility, there's a PDF accessibility checker. And I've just learned that Ulrike has also some more links for PDF checking. And I will extend the slides perhaps later. So the slides are also on the homepage of the TUG. So when I develop new features in PDF, I usually save the PDF, open Adobe Acrobat, check if it's okay, and then create a new feature. So it's a very tedious workflow because it takes a lot of time, and I cannot automate this. And I wish I could automate this. Debugging, speaking of debugging, I've shown this before where the PDF is okay, there's no syntax error in the PDF, but some logical error in my code somewhere. And there's how to debug this kind of problem. There are several debugging techniques to get to this kind of error. You can use a step-by-step debugger, like clicking on next, 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 to see where the program goes. I don't like this because it's too much time. You can do some kind of visual debugging. This is actually not from Boxes and Glue, this is from LuaTeX. This helps checking alignment things also. It's nice. My most favorite debugging technique is actually the printf debugging. We just write in some code, the input is A or something like that. So very simple, but it's actually the one I use most. Rubber duck debugging, this is, I put this in mainly for Polo. This is where you look at your rubber duck on the desk, explain the source code to the rubber duck, and then during explanation you find out, oh no, this is the incorrect place. And gladly, the rubber ducks cannot speak because they might embarrass you. So, printf debugging. It works only for simple cases. When doing typesetting, you sometimes have a lot of information on the page, nested data structures, boxes, inside boxes, lots of glyphs and other things, and there printf is getting hard to read. So it's too much output for data structures in typesetting. And now how do I understand the generated node list or the nested node list? I need some kind of structured output. I used to have this representation with the, my software based on LuaTeX. I create a dot file from the internal data structure, which you can use with GraphWiz and create some PNG or PDF output like this. But this gets really ugly because these lists can be so huge, and then you have to scroll through the document and find the right place which one you want to check. And then somebody came up with the another representation, Josef Friedrich. This is actually the one I like most because it's structured, but it's also a bit verbose, but it's very nice. You can use this with LuaTeX. And with Boxes and Glue, I switched to even more verbose output. It's based on XML. You see the node lists or the boxes nested inside boxes as HTML, XML representation. But this is really handy because you can load this into your text editor and use code folding. So to hide the inner boxes you don't need. And you can use some query language to find the positions where you want to look. So this is also from last year, my great wishes, what to implement next. Like experiment with the algorithms, doing optimization for page breaks and paragraph breaks, or to do parallel tasks to speed up things. And I have to admit I've done none of these items yet, so this will be on next year's presentation for my next steps. Okay, 2 conclusion slides. Importing TUG algorithms and data structures is possible. Development takes much more time than estimated. I know that's trivial, and I want to extend this a bit. Since I don't have a deadline for it, I can play with the code and throw away code when it's not good or if I go into the wrong direction. And this is a very great luxury I have because I don't have any boss sitting behind me and saying, okay, next week I need this thing done. Okay, and seeing the results keep my motivation high. Without that, I would not continue working. So the last conclusion I would like to conclude with this poem: roses are red, violets are blue, I create my PDF with boxes and glue. Thank you very much.
Thank you. Any questions? Not even Boris.
Everybody wants to go to lunch, I guess.
You ported the TUG algorithms. One of them is show node list. Did you port that too? That was Don's way of showing node lists when he was debugging.
Actually, I have never looked into this, so the answer is no.
It looks pretty much like the
There
last
was
slide you
like
had.
some parentheses around this with dots.
You should just set max depth and max breadth and then you get the full thing.
Okay. Actually, I have never seen that.
Look at it.
So why Go?
What?
Why the Go language as opposed to Rust is popular this
You
week?
have
or
to choose one,
Lua?
and it was just a language I know best. And there are several reasons, of course, for it. It's not just a random choice. With current implementation of LuaTeX, I create binaries for Windows, Linux, and Mac. But it's hard because I have some wrapper libraries around this, and I have to cross-compile it. And it's a bit tricky. And with Go, I can just cross-compile everything from one single step, for example. And this is actually a key feature for me. Other languages have that as well, but I had to choose a language.
You talked about how important performance is, and you said that you're getting around 5 times the speed of LuaTeX for simple. What's driving that improvement in performance? I would normally think of the LuaTeX code as already quite well optimized. So,
actually, I have no idea. No, seriously, I have this. I use the Lua API of LuaTeX, and I have just a few wrappers around this, not too many. But this somehow it's my code is not optimized, or this API is slow. I don't know. It's still very fast, and people come to me and say, "Oh, this is so fast, and InDesign is so slow compared to that." So I didn't think about it, but now I use also bare metal code. It's much faster, but I have not looked into it before.
Well, thank you. Next step is going to be lunch.